morning. Section 2.2 reviews several graphs that you probably already know, one of them being a scatter plot. This is our x-axis and this is our y-axis. And we typically use a scatter plot when we have something called bivariate data. Bivariate data means that we have ordered pairs for our data. So if you look below, I have a nice little table for us of the years of experience for a registered nurse and the annual salary in thousands of dollars. Now this is rounded to the nearest thousand just for convenience sake, and we don't have a whole lot of data values. In fact, 2, 4, 6, 8. So we only sampled, and we don't know where the sample came from, but we only sampled 8 registered nurses. You can see as the years of experience increase, you see a pattern of a general increase in the salaries. So there's a positive relationship between these two variables. In order to do a scatter plot, you just need to decide how you're going to run your tick marks and who is driving the show, so to speak. What's your independent variable? Which one explains the other? And so we seem to think that the x's would be the years of experience, would explain why you would make more money. So we're actually, instead of labeling this x, we're going to label it years, and this is money in thousands. Now, what you need to do on that xy axis is decide, all right, how am I going to graph this? Well, we went all the way up to 16 years, so maybe we would do 2, 4, 6, 8, 10, 12, 14, 16 years. And we would let the reader know some of the tick marks. I don't label all of mine. Now for the graph, since it doesn't start till 40,000, I would probably break my graph, so I show it with this symbol. And I'm starting at 40,000 and I need to go up to 64,000. So maybe I would go by 5s, but you would only see me label the 10s, maybe something like that. Honestly, this is a sketch and not a graph. If you really wanted a graph, you'd use graph paper. The purpose of the sketch is to see if there's some kind of relationship. And specifically, we're looking for a linear relationship. Our course only deals with lines, but you can have quadratics or exponentials. And so we have a half, and it's plotted up at 40. At 2, we're up at 43. At 4, we're at 45. At 5, we're at 47. At 7, we're up at, looks like 50. And then 9 was at 54. So I'm taking guesses at all of these values, right? 10, 2, 4, 6, 8, 10 was at 54. So same level. And then the last data point that I gave us, I think we jumped up to 16. So 16 was way up here. So for the most part, I do think that we see a linear relationship. I can kind of pick a line maybe that goes like this that represents that. But it's definitely positive. As one value increases, the other one increases. Pay attention to how the problem's worded, but typically it tells you which one's X and which one's Y. But in this case, we used our reasoning skills. It makes sense that the years would define the values for the salary. Thanks.